Select the major product of the following reaction sequence. So we have a starting material, which is an alkene. It's got that carbon-carbon double bond. And then we've got three different steps. So what we want to do to get to the product is take this step by step and see what it is that we are doing. So in the first step, you're adding HBr in the presence of hydrogen peroxide. So we are going to add HBr across the alkene. The hydrogen peroxide is there to initiate the radical reaction. And when we do a radical addition of HBr, we reverse the typical selectivity. So what we see is that the hydrogen ends up adding to the more substituted carbon, and the bromine adds to the less substituted carbon. And we call this pattern of addition anti-Markovnikov in terms of the regiochemistry. So we can say that this is for anti-Markovnikov addition of HBr, specifically to an alkene. So these are the conditions to reverse that normal selectivity. Without the peroxide, you would have added the bromine to the second carbon. And so now what we have, we started with an alkene, now we have a primary alkyl halide. And so we want to look at the second step. So we see that we have sodium cyanide and DMSO. So this is sodium, this is a salt, so we have sodium and cyanide, and that cyanide ion is a really good nucleophile. And DMSO is dimethyl sulfoxide. And this is an example of a polar aprotic solvent. So you've got a good nucleophile, a polar aprotic solvent, and a primary alkyl halide. These are the conditions for an SN2 substitution. So that means that this cyano group is going to attack the carbon that has the leaving group. This carbon should be partially positive because of that bond to bromine. So this is going to come and form a new bond and push off bromine as the leaving group. And so we can look at what that forms then. So you've got 1, 2, 3, 4, 5 carbon atoms that were in this main chain. And so we're numbering just for keeping track of carbons. I'm not worrying about how IUPAC would have me number this to name. And so I'm forming a new bond between this carbon that I've numbered as 5 and the nitrile. So there it is. So we have elongated this carbon chain. We've added an extra carbon atom. And then in the third step, we are treating this, so we formed a nitrile. We should actually label that functional group. So we have a nitrile. So nitriles, remember, are part of a class of compounds known as carboxylic acid derivatives. And so what we have in this last step, we've got H3O plus and heat. These are acidic hydrolysis conditions. And so nitriles, like all carboxylic acid derivatives, can be hydrolyzed to give the carboxylic acid. So this carbon atom 6 is where the water is going to add, and that will become the carboxylic acid carbon. So let's number to make sure we have the right number. And 6, so that's going to be where the carboxylic acid is. Okay. So this numbering is actually opposite IUPAC. Don't let that throw you off. We are simply numbering just to keep track of our carbon atoms. And I tend to just number the longest chain and then just kind of keep an eye on those substituents. So I'm not ignoring that methyl group. It's just not part of the chain. It is, however, on the carbon that I've labeled as carbon 2. So I just make sure that it's still there in each step. So this is, it looks like option B. So 1, 2, 3, 4, 5, and 6. Okay. And so the only other thing that's kind of close that might fool you is D. And that is short a carbon atom. But we can, however, if we want to take a look at this, we could, however, also make D from that same alkene. So it's just kind of as an aside. So if we wanted to make D, we would want to make sure that we do not add a carbon atom, right? So adding a nitrile wouldn't be a good idea because that has another carbon. We do know a way to add an oxygen anti-Markovnikov. and that's hydroboration oxidation. So that's borane in THF solvent. And as a second step, you need aqueous base and hydrogen peroxide. And so that would give you the anti-Markovnikov alcohol. And then this is a primary alcohol, and primary alcohols can be oxidized to give you carboxylic acids if you use a strong oxidizing agent like chromic acid. So to differentiate between this pathway and the one the question was asking you about, the key difference is the carbon chain. So remembering that when you add a nitrile, you're actually adding an extra carbon atom. So if you wanted to add the extra carbon atom, you would go this route. If you're wanting to keep the number of carbon atoms consistent, you would make the alcohol and oxidize it.